Okay, 13.3 rational exponents. Here we've got 36 to the 1/2. You just want to keep in mind that this top number is going to be our power. This bottom number is going to be our index. And we're going to turn these into radical expressions where we've got an index of 2. Index is always what goes in this little nook here. 36 underneath, and then in parentheses to the first power. Square root of 36 to the first power. Square root of 36 is 6. 6 to the first is 6. Number 2, 1 over 1,000 to the 2/3. Here we've got a fraction to the 2/3, and you just want to basically distribute that exponent, the 2/3, to both of those numbers. So 1 to the 2/3, 1,000 to the 2/3, and a little side note on this top one: 1 to any power is 1. It doesn't mean if it's 1 to the millionth, it doesn't matter if it's 1 to the negative 1,000th, it's still going to be equal to 1. So on this next step on top, we just have the number 1. And then, so with the bottom though, we'll still continue to think of the top number as the power, the bottom number as the index, and we'll make it the cube root, because that's our index, of 1,000. All that to the first power. Cube root of 1,000 to the, not the first power, second power. Power's 2. Cube root of 1,000, you can put that in the calculator and you should get 10. 10 to the second. 10 times 10 is 100. Number 3, 49/4 to the negative 1/2. So we're going to start off doing the same thing here. 49 now to the negative 1/2. 4 to the negative 1/2. Both those numbers to the negative 1/2 power. And one thing on these ones, if you've got a negative exponent, we're going to make the negative exponent positive by moving the base, in this case the 49 on top, moving the base through the fraction line. Make the negative exponent positive by moving the base through the fraction line. So that means that, let's see if we got a different color. That means that this 49 to the negative 1/2 is going to go through the fraction line. And since this 4 has a negative exponent also, it's going to go through the fraction line, but it's going to go up through the fraction line. So we end up with 4 and then now a positive exponent. 49 on the other side with a positive exponent also. And then we're just doing that power index thing again. Power. Once we've made it positive, and then the index. So we've got the square root of 4 to the first power, the square root of 49 to the first power. The square root of 4 is 2. 2 to the first is 2. Square root of 49 is 7. 7 to the first power, 7. Number 4, I put a star next to this one, negative 16 to the negative 1/2. And the main thing I want to point out here is that if the index is even, so we're meaning 2, 4, 6, 8. If the index is even, the base, which in this case is negative 16, must be positive. So hopefully you catch that at the beginning. if the index is even, the base must be positive. Here the index is 2, the base is negative 16. So, or I should say, otherwise, no solution. So if you've got negative 8 to the 1/4, index is even, the base is negative, so no solution on that one. If you've got negative 5 to the negative 1/2, here the index is 2, base is negative, no solution. Be careful. I don't know if this will come up, but if you have something like negative 5 to the negative 1/2, over here on these other examples, we had the parentheses around those, so the negative was included as part of the base. Over here, the negative isn't in parentheses, so that means the base is just 5. So this one you wouldn't say no solution, you just work on it like normal. But I think they'll just give you examples like number 4, like that one and that one. Number 5, x to the 1/4 to the negative 3/4 power. Anytime you've got an exponent to another exponent, you can go ahead and multiply these exponents. And multiplying is easy. Just multiply the tops, multiply the bottoms. Don't need a common denominator. So x to the 1 times negative 3 on top, 4 times 4 on the bottom. And then we're going to, any of our final answers, the exponents will need to be positive. So we're going to make this exponent positive. By moving the base through the fraction line. Make the exponent positive by moving the base through the fraction line. This one has an invisible fraction line underneath. So we're going to take this and move it through that invisible fraction line. On the next step, on the bottom, we've got x now with a positive exponent. And anytime you move something through and there's nothing left up there, we're just going to put a 1 on that side of it. And also with these variables, you know, if you have something like 8 to the 2/3, we're going to simplify this, making the 3 the index and the 2 the power. But if you've got x to the 2/3 or anything else, we're not going to go further and make 3 the index and 2 the power. We're just going to leave it. So final answer, 1 over x to the 3/16. Number 6, 5a to the 3/4 squared. Here we're going to multiply each exponent inside by 2. Multiply each exponent inside by 2. So that means this invisible 1, 5 has an exponent, that invisible 1. We're going to multiply that 1 by 2. We're going to multiply the 3/4 by 2. And we'll end up with 1 times 2 is 2. And then a to the 3/4 times 2. It might help if you think about that 1 that's underneath the 2. 2 over 1 is the same as 2. So multiply the tops, 3 times 2. Multiply the bottom, 4 times 1. And 5 squared, 5 times 5. And then 6/4, we can reduce that exponent on the a by 2. Number 7, 16x to the 4th to the negative 1/2. 4, this is 4 over 1. So again, we're multiplying each exponent inside. Multiply each exponent inside by negative 1/2. And 4 times negative 1/2 is going to be negative 4 on top. 1 times 2 on bottom. 4 over 2 is 2. Negative 4 over 2 is negative 2. So I'm just going to reduce that part of it. Well, I'll just reduce it here. Negative 4 over 2 is negative 2. On the next step, we're going to make the exponents positive. And hopefully you remember that there's this invisible fraction line underneath, and then part of this is going to need to move. The 16 is going to go through the fraction line, making the exponent positive. The x is going to go through and make the exponent positive. So we've got 16 now to the positive 1/2, x to the positive 2. And then when everything moves through, if there's nothing left on top, you just put a 1 there. Go a little bit further with this. We've got this number with a rational exponent. The 1 is going to be the power. The 2 is going to be the index. So in the next step, we've got the square root of 16 to the first power. Hopefully not too bad. Square root of 16 is 4. 4 to the first is 4. Number 8, 8 to the 2/3 times 8 to the 1/6. If we're multiplying, we got this little dot in the middle, so we're multiplying the same base, which is a. Multiplying the same base, we're going to add the exponents. That means we've got a to the a to the 2/3 plus 1/6. And you will need to know, since most of these exponents are going to be fractions, you will need to know how to add fractions. Multiplying fractions is easy. You just multiply the top, multiply the bottom. Adding fractions, though, we need the same common denominator. Hopefully they're not too difficult for you. Most of these numbers, if you've got something like 3 and 6, common denominator is going to be 6. 3 can go into 6. 6 can go into 6. So in this case, 6. And that means that this 2/3 is going to need to change so that it's got a denominator of 6, which means we're going to need to multiply 2 to get it there. So this now is going to be a. If you multiply the 2 by 2, you get 4. The 3 by 2, you get 6. And now we can add that 1/6. 4 plus 1 is 6, and we keep our common denominator. Keep our 6. And since that's a variable, a to the 5/6, we're not going to make the 6 the index and the 5 the power. We're just going to leave it. Number 9, 3x to the 2/3 times 2x to the 4th times x. Here we're going to multiply the numbers. So 3 times 2. And then we're going to multiply the x's by adding the exponents. Multiply the x's by adding the exponents. So I'll put x, and we've got 2/3 plus 4 plus, here we've got an invisible exponent on that x, the 1. So adding all those exponents. And you might even, since we're going to be adding a fraction, you might put a 1 underneath both of those. 2/3 plus 4 over 1 plus 1 over 1. Make sure you keep in mind when we're adding fractions, we need a common denominator. With 3, 1, and 1, hopefully you can tell that 3 is going to be the common denominator. So in order to get this 1 underneath the 4 to 3, you got to multiply 3. In order to get this 1 underneath the 1 to 3, we got to multiply 3. Make sure you do that on top and bottom. So now we've got 6x to the 2/3 plus 4 over 1 multiplied by 3 is 12 over 3. 4 times 3, 1 times 3. And then 1 multiplied by 3 is 3. And the same on the bottom. And then we've got 2/3 plus 12/3. That's going to be 14/3 plus another 3, 17/3. Our common denominator we keep. Make sure when you put this in the computer that you've got your exponent raised up. You don't want to write x and then 17 over 3 like that. You want the 17 over 3 to be an exponent. So make sure you're doing that. Number 10, a to the 5/6 over a to the 2/3. Fraction line is also a division problem. So if we're dividing the same base, both of these are a. Before, when we were multiplying the same base, we added the exponents. If we're dividing the same base, we're going to subtract exponents. And there's different ways to do this, but I'm going to recommend that you subtract on top. Do the subtraction on top. So this is going to be a. We got that fraction line underneath. 5/6 minus 2/3. Subtracting these exponents here. And we do have that fraction line underneath, but I don't need it right now, so I'm going to leave it off. We need a common denominator here, hopefully with 6 and 3. You can tell that 6 is going to be the common denominator, so we're going to have to multiply by 2. So a to the 5/6 minus 4, 2 times 2, and then 3 times 2. So 5/6 minus 4/6, then we end up with a to the 1/6. So do the subtraction on top. If we'd ended up with negative 1/6, we would have moved the a to the bottom in order to make that exponent positive. Number 11, a to the 2/3, a to the 1/6 over a to the 4th. Here we're just combining both of those things where we're multiplying on top. If you got a's butted up against each other, that means we're multiplying. We got a on the bottom, which means we're dividing also. We're going to go ahead and do the multiplying up top, and then we'll do the dividing. So on top, when we're multiplying, we're going to add exponents on top. So we end up with a to the 2/3 plus 1/6 all over a to the 4th. Not doing anything with the a to the 4th yet. On top, with the 2/3 and the 1/6, we need a common denominator again. 3 and 6, the common denominator is 6. So on this first fraction, we're going to multiply 2 in order to get that 3 to 6. So we got 4 over 6, multiplying 2 on top and bottom. So on top, 4/6 plus 1/6 is 5/6. So we added exponents on top. Now we're going to subtract exponents on top. So we've got a to the 5/6 minus 4. And I'm going to put 4 over 1. Because we will need a common denominator. With 6 and 1, our common denominator is going to be 6. So we've got to multiply 6 in order to get that denominator right. So we've got a to the 5/6 minus 4 times 6 is 24. 6 times 6 is 6. And then we end up with a to the 5 minus 24 is negative 19 over 6. And this we've got to make positive. Got that invisible fraction line underneath. Gonna make it positive by taking the base through that fraction line. So now we've got a with a positive exponent, and then since everything on top left, we just throw a 1 there. Okay, 2 more. Square root of y to the 5th over cube root of y squared. Here we're going to do the reverse of something we did at the beginning. We're going to turn this radical into a rational expression, a variable with a fraction exponent. You'll want to remember with this square root up top, there's an invisible 2 there. And we're just going to convert this. The power is going to go on top, the power, y to the 5th power, the index, the 2 on the bottom. Index on bottom, power on top, and then same thing with the y. You got the 2 on top, which is the power, the index, which is 3 on the bottom. And as long as you can do that, then we're just subtracting exponents. And then make sure you do that on top. 5 halves minus 2/3. Five halves minus 2/3. Doing that on top. We do need a common denominator. And then hopefully you can guess with 2 and 3, the common denominator is going to be 6. So to get from 2 to 6, we've got to multiply 3. To get from 3 to 6, we've got to multiply 2. And make sure you're doing the same on that top number. So 5 times 3, 2 times 3. We end up with y to the 15/6 minus 4/6. And that ends up being y to the 11/6. And the last one, 8x to the 3rd to the 1/3 times 8x to the 1/4 to the negative 2 power. Multiply each exponent inside by 1/3. That includes that invisible 1 on the 8, both those 8s. In the second parentheses, we'll multiply each exponent inside by negative 2. So we've got 1 times 1/3, and then 3 times 1/3 ends up being 3 over 3. So we'll just make that x to the 1st. 1 times negative 2 is negative 2. And then 1/4 times negative 2 is negative 2 over 4, which reduces to negative 1/2. So these two make negative 2 over 4, which reduces to that. And there's a couple ways you could go from here. We do have 8s that we can add the exponents for. We've got the same base there, 8 to the 1/3, 8 to the negative 2. There's a lot of different routes you could take that are perfectly fine. None of them are really any faster than the others. On this one, I think I'll go ahead and we'll do something just slightly different, and I'll make these, well, I'll make these exponents positive first, and then we'll deal with them. We've got this invisible fraction line underneath. We could make this positive by moving it through. We could make this positive by moving it through. So now we've got 8 to the 1/3, x to the first, and then on bottom 8 to the second, and x to the 1/2. And just because I know this comes up on a few of them, we'll go ahead and simplify this. Make this the cube root of 8 to the first. And then on bottom, 8 to the second is just 64. 8 times 8. Cube root of 8 is 2. 2 to the first is 2. Then we've got x to the first, 64, x to the 1/2. And then a couple things we could do. Reduce by 2. And then also with these x's on top and bottom, we can go ahead and subtract the exponents. So 2 reduced by 2 is 1. So we've got x. If you take 1 minus a half, 1 minus a half is just a half. And then 64 reduced by 2, reducing these parts by 2. That becomes 1. I left off the 1 in front of a variable. 64 reduced by 2 is 32. And that's it. That's probably going to be the trickiest one that comes up when you've got two parentheses multiplying with different things inside those. But hopefully the rest of it made a whole lot of sense. And good luck. Message me if you have any questions.